This lesson will follow Module 4, Lesson 5 from the Eureka product, so we know it's going to be good. This is about the zero product property. Let's see. This here says, consider the equation A times B times C times D equals 0. What values of A, B, C, and D would make this equation true? Think of, okay, go ahead and press pause so that you can think about it. Hopefully you came up with the idea that A, B, C, and D can be any numbers as long as one of them is 0. Because if A is 0, 0 times anything else is going to equal 0. If C is 0, 0 times anything else is 0. So as long as one of these is 0, the product will be equal to 0. So this leads us to the idea of the zero product property, which says if A times B equals 0, then A equals 0 or B equals 0, or they can both be equal to 0. If any one of them is 0, then the whole thing will be equal to 0. Of course, this would apply to any set of numbers like that previous example. It doesn't have to be two numbers. It can be 5 numbers multiplied together being equal to 0. If any one of them is equal to 0, the product will be equal to 0. Okay, now we're going to try to solve these 4 equations, or we're going to find values of C and D that satisfy the equations. And notice there can be more than one correct answer. So I want you to press pause, try number 1, then press play, pause from number 2, press play, etc. Okay, for number 1, here's one solution. C equals 97 and D equals 0. It turns out there are millions and millions of solutions. C can be equal to anything as long as D is 0, or D can be equal to anything as long as C is equal to 0. So there are infinitely many solutions for this. Press pause as you think about number 2. Well, I'm not sure why this example is here for this section, but Eureka put it, so we'll talk about it. Because this is not equal to 0. But I also think there are infinitely many solutions. For example, when D is equal to 2, this would have to be equal to 1, so C would have to be equal to 6. Let's see, when D is equal to 5, this would have to be equal to 2/5, because 5 times 2/5 equals 5. So let's see. What minus 5 equals 2/5? I believe 5 and 2/5. We could keep doing this forever, and we're going to come up with all kinds of pairs of solutions. Some will be fractions, some will be decimals, some will be whole numbers. Go ahead and think about number 3 and press pause. Okay, so if C equals 5, then this would be equal to 0. Then D can be equal to anything. Or if D is equal to 0, then C can be equal to anything as well. Go ahead and press pause for number 4. I have a product being equal to 0. So if A equals 0, it equals 0. Or if B equals 0, it equals 0. When does this equal 0? When C equals 5. When does this equal 0? When D equals negative 3. So when C is 5, D can be equal to anything. And when D is negative 3, C can be equal to anything. Okay, so now we're on page 24 of the student book. Go ahead and read over the whole problem, and as you press pause, and then press play when you're ready. Okay, so the area of the rectangle is this trinomial, and they ask us to express it as the product of 2 binomials. That sounds like factoring, which we've covered thoroughly. So I already did it. Y'all know how to factor this. I now have the product of 2 binomials. And then they want us to draw and label a diagram. There it is. Now on page 25 it says, suppose the area is rectangle, which we had from the previous page, to be 21 square units. Can you find the dimensions in terms of x? So obviously we need to solve this equation. looks like they're going to give it to us a little bit at a time. So D says rewrite the equation so that it is equal to 0 and then solve it. Press pause as you try to do what it says here. Alright, first they told me to make this equal to 0. I can do that just by subtracting 21 from both sides of the equation. And I'm going to get x squared plus 2x minus 24 equals 0. And they told me to solve this. Alrighty, so I have to solve this equation. We haven't seen anything like this before. So we're going to use what we have learned already about the zero product property and about factoring trinomials. So I'm going to go ahead and factor this trinomial. We know how to do that. Okay, I went ahead and did this. I factored this trinomial by the box method that we know. If you want to do it by grouping, that's fine too. And this is what I come up with. So now I have the product of two binomials, this is a 6, equals 0. So if either one of these equals 0, this will be true. Well, when is this equal to 0? Well, that's pretty simple. When x equals 4. When is this equal to 0? When x equals 6. So x can be equal to 4 or 6. Either way, it will work. So my solution set is 4 and 6. Okay, hopefully you caught on to my little bitty error that I did on purpose. This right here is just going to be x plus 6. So when would this be equal to 0? When x is negative 6. So my solution set is 4 and negative 6. I'm glad you caught it too. All right, now question E was a little bit tricky. I had to think about it for a bit. If you remember, the original dimensions that we had back from question A was x plus 3 times x minus 1, and that equaled the area of 21. Now we have two solutions here that work for the equation, but not all of them necessarily work in reality. So for example, when x is negative 6, we can end up with negative 3 times negative 7 equals 21. Okay, that does work. It should. But think about it. That would mean that one of the sides is of length negative 3, the other side is of length negative 7. That doesn't make sense. Sides can't have negative lengths. Well, let's see what happens when x is equal to 4. This would be 7 by 3, which equals 21. Okay, and you can have positive lengths. So the actual dimensions are... Okay, now go ahead and try to work F. Press pause and come back when you're ready. Okay, at first glance this might seem confusing because I think they might be asking us to find the actual dimensions, but I think they just wanted the dimensions in terms of x. So I can simply factor this and get x minus 5 times x plus 1. So the dimensions of the rectangle are x minus 5 times x plus 1. Now go ahead and read and try G, and then come back when you're ready. Alrighty then. I believe that 1/3 of 21 is 7, so this is the equation that we want to solve. I want to make this equal to 0, so I can use the zero product property. So I'm going to subtract 7 from both sides and get x squared minus 4x minus 12 equals 0. Then I'm going to go ahead and factor this trinomial. Okay, I went ahead and factored that trinomial. You know how to factor them. So if either one of these is equal to 0, this equation will be true. So here, when x equals 6, the equation is true. And here, when x equals negative 2, this equation will be true. So this is my solution set for this equation, but we need to see if these make sense for the actual problem. Okay, so these are my possible values for x, and if you remember, these were the original dimensions of the rectangle that we got in question F. So let's see. When x is 6, this would be 1 times 7. That sounds legitimate. 1 times 7 is 7, the area. When x is negative 2, this would be a negative 7 times a negative 1, which does equal 7, but you can't have negatives. So the actual dimensions are 1 by 7. So the actual answer for G is 6, because the negative 2 did not work in context of the problem. Okay, so here are four equations. We'll call them quadratic equations because that's what they are. Go ahead and try to solve each one. Press pause, come back when you're ready. We'll do one at a time. For number 5, I will try to make this 0, so I'll add 5 to both sides. And I will get x squared minus 11x plus 24 equals 0. I will then try to factor this trinomial. I can do that in my head. That's x minus 8 times x minus 3 equals 0. When is this equal to 0? When x equals 8. When is this equal to 0? When x equals 3. So this is my solution set, although it should be written in numerical order. Go ahead and try number 7. I'm going to try to make the right side equal to 0 by adding a positive 7. And I will get 7r squared minus 14r plus 7 equals 0. Now I have a trinomial equal to 0, so I will try to factor that. Okay, I went ahead and factored this. First I did my greatest common factor. I factored that out. Then I basically unfoiled this, or I could have recognized that this was a perfect square trinomial and got a binomial squared. These two are exactly the same. Well, 7 can never be equal to 0, but when is r minus 1 equal to 0? When r equals 1. So that is my solution, or this is my solution set. Go ahead and try number 6. Okay, for number 6, it is already equal to 0. So all I have to do is factor. I have a common factor of x. And I need to figure out when are these equal to 0. Well, this factor is equal to 0 when x is equal to 0. That was simple. Now, when is this equal to 0? You can figure it out in your head, or you can say, well, when is this equal to 0? When it's equal to 0. Solve this equation, subtract 1 from both sides, and then divide both sides by 7. So my solution is x equals 0 or negative 1/7. So I can write my solution set as negative 1/7, 0. So you can write it like this, x equals 0 or negative 1/7, or you can write it like this. Go ahead and try to do number 8. Okay, this one is also already solved for 0. That's great. So I'm going to factor out a common factor which does not exist. So I'm going to try to do my unfoiling. I'm going to do it by the dot box method. I'll be back in a second. Okay, so here was my box method. I was basically looking for two numbers that multiplied together to give me negative 24, and then added up to positive 5. So I came up with a 8 and a negative 3, and then I did what y'all all know that we should do. So when is this equal to 0? When d equals negative 4. That's obvious. When is this equal to 0? Let's see. When is it equal to 0? Add 3 to both sides. You get 2d equals 3. Divide both sides by 2. You get d equals 1.5. So d equals 4, negative 4, or 1.5. Well, my solution set is negative 4, 1.5. All right, so let's go ahead and look at this lesson summary on page 27. The zero product property. If two numbers multiplied together equals 0, then if either one equals 0 or if both equals 0, it is true. When solving for a variable in a trinomial, set the product of the binomial factors equal to 0. Using the zero product property, you know that if one binomial factor is equal to 0, then the product of all the binomial factors is equal to 0. Going one step further, when you have a set I'll start that again. Going one step further, when you have set each binomial factor equal to 0 and solve for the variable, all the possible solutions for the variable have been found. Given the context, some solutions may not be viable. Like, for example, you cannot find out that Billy is negative 12 years old, so that would not be viable. So be sure to recontextualize your solution to determine if they are appropriate. Does your answer make sense in reference to the problem? Well, that brings us to the end of that lesson. And for those of you who are not in class today, you're going to want to do the problem set on page 27 of Eureka, which I have loaded onto my web page. Have a great day.